Okay, in this section we're going to take derivatives. So don't forget you have the chain rule and you have some trig. So let's start with the first problem, number 21. So taking my derivative, you're going to use perfect notation. So that's going to equal, take your derivative by doing the power rule. Here's power rule. I need these parentheses. I'm going to raise it to the 6th power, and then I'm going to take the derivative with respect to x of what is inside. Now you don't have to do all these steps. As long as you get the right answer, I'm good. Okay, that derivative is going to be 4x, just plain old 4x. So now I'm going to clean this up, and you have to do this. Take your 4x and multiply it by the 7. That's going to give you 28x. And then you have 2x squared plus 5 to the 6. Here, I'm going to erase this so that we don't have to get confused. Okay, so this is your final form. Don't forget to multiply. Don't forget this power. Frequently people are thinking ahead to taking the chain rule and they forget to put the power there. So let's go on to 22. Okay, in problem 22, the first thing I'm going to do is rewrite it so that it's in a form that I can take the derivative. So use parentheses, x squared plus x. That's raised to the 1/3 power. Now take your derivative. 1/3 x squared plus x. 1/3 minus 1 is negative 2/3. And then take the derivative with respect to x of what is inside the parentheses. So, continuing to work, I have 1/3. I have x squared plus x to the negative 2/3. And then that derivative in parentheses is 2x plus 1. Okay, so now what I'm going to do is we're going to clean this up a little bit. So I need more space to work. So I think what we'll do is I'm just going to put it on the next page. Alright, continuing now to make this look better, and you're going to do this when you have your answer. You're not going to leave it like this. I'm going to have the 2x plus 1 in the numerator. I have a 3 in the denominator. Alright, so that's taken care of. Let's change this. Taking care of this, and I'm taking care of this. Now, look what I have also in the denominator. The x squared plus x to the negative 2/3. So let's put that in the denominator as well. So what I could really do is make it look really pretty and give myself the 3rd root, and then I'm going to take my x squared plus x and raise that to the 2nd power. And now I'm just going to continue this line out so that you see that that's the whole denominator. Now, do you have to do this? At this point, I'm going to say yes. You should be able to make your answer look like the form in which they gave you the initial problem. So be able to get it like this. It doesn't take a lot, but it certainly is in the nicest form, and you've been in honors calculus for a while now. Okay, here's problem 23. My first step is to write it so that it conforms to my ability to use the power rule. So I'm going to take this entire denominator and bring it up. When I do that, my power is to the negative 6th. So now I'm going to start taking the derivative. Notice that my notation has changed. Okay, so let's see what we have. Taking the derivative now, I want to use the power rule. Bring down your negative 6. Whatever you have in here, just bring it in the way it is, and then go more negative by 1, so that makes that negative 7, and then you're going to take the derivative of what was inside, which was x squared plus 2x plus 5. Okay, this derivative right here will be 2x plus 2. Alright, so let's clean this up. So my final answer should be in this nice form. F prime of x equals. Now, I would just put the negative 6 here. Then in parentheses, I would put the 2x plus 2. That is the safest way to write that. Then in my denominator, I would put my x squared plus 2x plus 5 and raise that whole thing to the 7th power, and that is the nicest way and the safest way to present your answer. So let's go on to number 24. Okay, in 24, I first want to write this in the safest form possible, and that form is going to be f of x equals tan, here's your angle, 10x, and then the entire thing is raised to the 2nd power. So now let's start taking our derivative. F prime of x equals, okay, take the derivative using the power rule. Bring down the 2. You never touch what's inside the parentheses when you do the power rule, so don't start doing that now when you have a trig function. That's just raised to the 1st power. Now you don't need that one, but it may help you do things correctly. Now take the derivative of the entire tan 10x. That's going to be secant squared 10x. Now take the derivative of the 10x. So that's going to be 10. Do not leave your answer like that. You've got to take this 10 and bring it to the front. And yes, you have to do that. So this is a 20. I then have tan 10x. And then I have secant squared 10x. And that is your final answer, and that's what I expect you to be able to give me back. Okay, let's do number 25. Okay, 25, I see I have a trig function again. So let's start taking the derivative. The derivative equals the derivative of sine x is just plain old cosine x. Okay, minus. Now I have a power. So I could have taken this and written it as cosine 2x the whole thing squared. That would be safer. Okay, so now what I'm going to do is let's start working through that derivative. So I have a minus because I had a minus here. I'm going to now put this in a bracket because everything that follows is going to be subtracted. So use your power rule. So I have 2 times the cosine of 2x, and that is now raised to the 1st power. Now take the derivative of cosine. That derivative is negative sine, don't change angles, and then take the derivative of the angle, which is 2. Alright, now let's put this all together. Okay, nothing has changed with the first term. It's still cosine x. Now, what you have to clean this up. You cannot leave this negative embedded. It's going to look like it's a subtraction sign. It is not. It's a negative sign. So that negative times this negative makes the whole thing a positive. So here's my positive. Now let's see what else we can start combining. This number and this number can be multiplied and should be multiplied. So that's going to be a 4. So now I've taken care of the sign, I've taken care of the number, and this number. Now come your trig functions. So I have cosine 2x, I don't really need that, and then times sine 2x. And that's how your answer should be. You should never, ever, ever, ever leave this negative embedded in the middle of an expression. Okay, this is your final form, and that's what I expect to have as an answer. Okay, let's go on to question number 26, which is the last trig question. Alright, in question 26, they ask you to take the derivative of cosecant. Well, you don't know the derivative of cosecant, so your first thing that you would do is make that 1 over sine 2x. So the 2x does not stay in the numerator, it comes along with the angle. So then that means I could write this as sine 2x raised to the negative 1 power. So really, that is your function that you will now take the derivative of. So let's start out with that function as opposed to starting out with cosecant 2x. Alright, so take your derivative. You have a power. You should be expecting 2 trig functions and the derivative of the angle. So power rule, negative 1 sine 2x, that's raised to the one more negative, so negative 2. Take the derivative of sine 2x, that would be cosine 2x. Take the derivative of 2x, which is 2. Do not leave it like that. Okay, the 2 gets multiplied by the negative 1, and you have a negative 2 times the cosine 2x, and then your sine 2x belongs in your denominator, and you can write it again in the traditional form because you are done with the problem. That is the best form, and that is the form I expect from you at this point in calculus.